Welcome to lesson 14. Have a go in your own time. There's a solve question there. Right, the answer is q equals 10. I'm going to solve it by inspection first, because as usual I want to highlight this important technique. Oh look, well that's over 4. I guess I could make the others be over 4 as well, and then it's going to look the same. And so I'm starting off with look this, because I'm like, can I do it by inspection? Not yet. So I'm going to first make it look the same. So the first thing, and then in a minute I'll do by inspection. So that's 2 over 4. I'll leave q over 4 as it is, and that's, well, I times for 12 over 4. I'm just going to check that. What's 12 divided by 4? 4, 8, 12. Yep, that works. So now, by inspection, I can say, I can say that, 2 plus q must be equal to 12. So I minus 2 from both sides, q equals 10. A more traditional way, which is maybe the better way, would be to say, but who knows, would be to times everything by 4. So you've got 4 times a half plus 4 times q over 4 plus 4 times 3. Equals 4 times 3, sorry. 4 times a half ends up cancelling to 2. They just cancel, that makes q. 4 times 3 is 12. Minus 2 from both sides, q equals 10. There we go. Now, warning on the next question. This is difficult. I don't know. I think you could argue this is, you may have just done this already, or you might find this is okay. But I think for quite a few people this might be one of the most difficult questions in all 20 lessons. So have a go, be patient, and I'm obviously just going to talk us through the answer in a minute. So the actual answers are x equals minus a third, or, because like it's an x squared, so I guess it's going to be one of these ones where it's or x equals minus a half. So that's the answer. I'm now going to talk us through and obviously you can just skip if you don't want to listen to this. One equation, two unknowns, because x squared and x are two different objects. But we can solve it because we can use the trick. Because it's a quadratic, it's something squared and something that's not squared, so I can do it like this. I'm just going to home straight in on the 1. There's only one, that you can only make that with 1 times 1. Bingo. Straight away this looks great. What are we going to do on the other side? Well, 6, they're both going to have an x, but x times x is x squared, so, well, it could be 1 times 6, or it could be 2 times 3. What do I mean by that? Let me just write that slightly differently. It could be x times 6x, or it could be 2x times 3x. Those are the ways to make 6x squared. By the way, you might be thinking there's more options. I'm going to put a pin in that. I'll come back to it later. Anyway, so basically you can just try them both out and multiply them out and see which one works. And this is the one that works. And which again I'm going to put a pin in, so I've now put 2 pins in. So now let's make both say, oh, we've got two things multiplied together to make 0. One or the other must be equal to 0. So either 2x plus 1 equals 0, or 3x plus 1 equals 0. I'm going to minus 1 here, which gives me 2x equals minus 1. Then I'm going to divide by 2, which gives me x equals minus a half. And then here I'm going to minus 1, which gives me 3x equals minus 1. And I'm going to divide by 3, which gives me x equals minus a third. Boom. There we go. There were 2 pins there, weren't there? So let's go back to them. Let's go back to this first one here. You might have been thinking, whoa, wait, Duncan, it could be 6x squared times 1. So couldn't the brackets be like 6x squared plus 1, and then 1 plus 1? Because surely 6x squared times 1 makes 6x squared. Here's the thing. You just got to get used to the fact that basically you always have an x on each side. That's just kind of how it works. Am I set? Wait, Duncan, I thought you said that maths was always logical. Well, it is logical. That's an intuition you build, because eventually whatever else you try won't work. So blah blah blah. Second pin. I put a pin in this, didn't I? Do you remember? Because I said, oh, I know what I was going to do. I was just going to multiply out and prove it to you. So let's just write this out. In case you're thinking, oh, but can you just multiply out and show me? So I'll just do that now. 2x times 3x. 2x times 3x plus 2x times 1 plus 1 times 3x plus 1 times 1. Now let's simplify them. So this one is going to be 6x squared plus 2x plus 3x plus 1, which then simplifies as 6x squared plus 5x plus 1, which is what we wanted because that was the original question if we look up at the top. And if we tried a different one, it wouldn't have worked. Let's do the next question. Have a go in your own time. I'm going to do this by inspection and say that y is obviously equal to 8. Well, because the cube root of 8 is 2. You might have done this. You might, in fact, let's not use an arrow, let's just go straight down here. You might have done a circle, done a box, and put a cubed. So I'm going to cube both sides. In which case you get cube root of y cubed equals 2 cubed. They cancel, which means you get y equals 8. There is a problem with that, which is there is a risk that you create new solutions. There's a risk. Because you've just cubed it. And if you cube something, you might be creating new solutions. It doesn't appear to happen in this case, but just be aware, just be careful. It's a similar risk if you try like squaring both sides, that kind of thing. You always got to be a little bit careful. If you're doing things like squaring and cubing. Anyway, let's do the next question. By the way, I sometimes kind of race ahead, and I'm sure that sometimes there's some people thinking, oh, I was just looking at that. Remember, you can always pause the video if you want to spend more time looking at something. Right, here's another solve question. Have a go in your own time. And the answers are a equals 0 and b equals 0. I'm now going to look at y. Could be 2. I'm going to take this equation here. And I'm going to add b to both sides. So that means that a equals b. And then, well, I'm going to take that one and that one. If a equals b, then I can replace that b with an a. So that means that a plus a equals 0. So that means 2a equals 0, simplifying. Divide by 2, a equals 0. Oh, wait. So that explains that one. Oh, wait. But a plus b equals 0. So if a equals 0, that means 0 plus b equals 0. So b equals 0. There we go. We've done it. Let's do a subject one again. Make m the subject. Have a go in your own time, obviously. Right. The answer is m equals q minus 11 minus x. I'm just going to do it. I personally do not like having minus m. Really bugs me. So I'm going to add m to both sides. So it gives me 11 plus x plus m equals q, because obviously I'd have minus m plus m, which cancels. So I now need to shift everything away from m, because I want m to be on its own. So I'm going to, let's minus 11 from both sides. So that means x plus m equals q minus 11. Now I'm going to minus x from both sides, because that gets rid of the x. So m equals q minus 11 minus x. Ta-da! Next question. We've got another solve. What a surprise. Right, so that's x to the 11 equals minus 1. Have a go in your own time. Not possible. Because suppose x were 1. What's 1 to the 8? 1 to the 8 is 1. Suppose x were minus 1. Minus 1 to the 8 is 1. because it's always positive, because x to the 8 is like x squared in that whatever you do, you end up with a positive number. So it's not possible. We'll do a calculate question again where we just have a little list. So I'll let you know when I finish the list. There we go, done. Have a go in your own time. And I'm going to write out the answers. And then obviously, as usual, I'll talk about the answers afterwards. Jump to the next question if you're happy. 2 plus 1 is 3, so we end up with 1/3. 2 plus 1 is 3, so we end up with 3/2. What's a half plus a half? Well, remember the circle, a half plus a half, that makes 1. 3 plus 5, 3 plus 2 is 5, easy. Now this one, it's amazing how often we can make little mistakes with minus numbers. I make a lot of mistakes with minus numbers. Well, I don't anymore because I've got this rule, which is that whenever it's a minus, I always double check my answer. Anyway, so that's -1. Minus 3 times 2 is -6. What does the minus mean? That means flip. So we end up with 4/9. But we haven't done the 2 yet, because remember, a power and indices, is that good English? I'm not sure, is a series of instructions. We haven't done that instruction yet. What is 4 squared? What is 4 squared? So that means 4/9 times 4/9. 4 times 4 is 16. 9 times 9 is 81. There we go. And we've got a similar situation here. The minus means flip, so we end up with 4/9. Just get rid of the answer just briefly so we can talk about it more easily, so I don't get stuck for space like I did with the other one. What does half mean? Half means square root. Well, square root of 4 is 2, square root of 9 is 3. I'm just going to briefly look at this in case you want to, because you might be thinking that was a bit weird, because I'm not sure we've done that before in this series of lessons. What's 2/3 times 2/3? It's 4/9. So we could say, therefore, that the square root of 4/9 is 2/3. I generally find that people just kind of slowly get used to this. If that's a bit weird, then just give it some more days, repetitions, and it will start making more sense. I've got a little true or false. If you watched my advanced introduction, you'll know that I'm not keen on doing this in videos too much, but I feel like it works here. Right, take your time. The answer is true, 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 true. They're all correct. This is the important one, which I'd like you to try and remember. Or maybe you know this already, which is fine. I'm not going to spend too long on this. And I didn't even mention this in the list of things, kind of topics, and this is kind of ish a topic on its own, but I thought it was worth touching on. So this is a very important skill. I'd just like to do a little mini proof. What's the square root of 9? 3. What's the square root of 4? 2. What's the square root of 36? 6. Oh look, 3 times 2 is 6. So that one works. What's the square root of 4? 2. What's the square root of 4? 2. What's the square root of 16? 4. Oh look, 2 times 2 is 6. So that one kind of feels alright as well. What's the square root of 25? 5. What's the square root of 4? 2. What's the square root of 100? 10. Oh yeah. So For me, I find this really helps. Helps me kind of go, okay, yeah, no, I'm, I'm happy that, it's not a perfect proof, but that'll do. And you can make more examples. Remember, just one example is not enough because it just could just be like a fluke. Simplify if possible. So just a reminder that the answer might be not possible. That's all of them. Have a go in your own time. And the answers are X, AB over EF, and not possible. X to the half means square root of X, and the square of X times the square of X is X. Remember the whole thing where like the square root of 9, square root of 9 is 3. Whoa. Is 9. Or the square root of 25, square root of 25 is 25, that kind of stuff. This one here, that is essentially A times B times C times D divided by C times D times E times F. The C's cancel, the D's cancel, you're left with the A and the A and the B and the E and the F. And finally, at the bottom here, you've got two completely different objects. It's like an elephant and a giraffe. There's nothing you can do. Because whenever you see a minus, you can think of it as like, if you're just conceptualizing to a certain extent, it's just like a plus. It's like we can't add or take away things that are completely different from each other. Let's do the next question. This is a plot, but what am I going to do? I'm going to cross it out because we're just going to be doing sketching in this course of lessons. But obviously, if you get asked to plot things in other situations, you might have to do it more neatly. Obviously, let me just write out the question first. Okay, so have a go in your own time at these. I'm just going to draw the axes. So I've got something to draw the answers on. So when I'm sketching, I always draw an axis, or I always draw both axes, and I write the 0 on so I can see where the origin is, and I label the axes and I put an arrow. Why the arrow is important? Because that shows the direction in which they're positive. So that is, in my experience, what you need to get full marks for laying out the axes in a sketch question. Right, so there are my answers. I'm just going to scribble out and write it. That's a 3 and that's a -1 over here. Move on to the next question if you feel ready. Remember, maybe that's 1 and 1. Maybe this is -2 and -2. So it's basically, if you plot a series of points where x and y are the same, you end up with this line here. Let's just put the original y equals x here. And what does y equals x plus 3 means? It means that y is equal to x, but then you add 3 to it. And so you're just simply adding 3. So you increase the y value by 3 everywhere, which essentially lifts the line in the air. And here, it's exactly the same, except you're minusing 1, so you're lowering the line. Let's move on to the next question. Have a go in your own time. Again, because it's a function question, I've not bothered writing an actual question. Okay. The answers are 15 and 0. So skip to the next question if you're happy. Oh look, what's inside there is k squared. And that's k squared. Which means we could alternatively write this as f of x equals 5x. Which means you're simply multiplying it by 5, because look, you're just multiplying it by 5. So you're just multiplying it by 5, and you're just multiplying it by 5. There we go. We've got 3 things here. So there's 3 things to factorise, so let me just write them all out. Have a go in your own time. And I'm now going to talk these answers through. So you can skip to the next question or you can watch me talk the answers through. So when we're factorising, the first thing we're trying to do is find something that's inside that they've all got in common. So in the case of this one, they've both got an x. So I took an x out, and then that was it. That was the final answer. And on this one, I noticed they all had an x squared. So I could write x squared, and then this is what it looked like inside the bracket. Okay. What's the second step? The second step actually is that you keep trying again, and you see if there's anything else that you can take out, and there isn't in this case. The second step is that you then try and do double brackets. Well, we don't do double brackets because we don't need to, because that's it. In the case of this one, yeah, we do double brackets, and that's how we get that answer. So this is potentially becoming quite confusing. I'm just going to plow on. I'm putting a pin in this. I'll come back to it in a minute. And then with this one over here, oh look, I can turn that into double brackets because it's an x squared next and a number. Oh, whoops. Bingo. If that really is very confusing, then maybe just leave it behind, or maybe just replay the video tomorrow and see if it makes sense. Or you could find some extra practice, or just not worry about it. You know, my theory when you're learning something is that you don't have to literally learn every single thing. Well, it depends. I mean, if you're like piloting a spacecraft, you probably want to learn everything just to be extra safe. But if it's a maths exam, not everyone is aiming for 100%, which means you're trying to focus your time. Anyway, blah, 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 that's my point. So, and also, if you just touch a subject a few times, it gets a bit easier each time. You don't have to completely understand it the first time. Anyway, whatever. I just wanted to, because I just put a pin in it, I just want to come back to this. Let's practice factorising it. Let's do, how do we make x times x? X squared, we x times x. And there's obviously going to be, it's 2 pluses, it's going to be 2 plus signs. And then how are we going to make the 6? Well, the 6 could be 2 times 3 or 1 times 6. So we could try both. I'm going to do the wrong one first. I'm going to just demonstrate multiplying it out to check. So that's x squared plus 3x plus 2x plus 6, which is x squared plus 5x plus 6. No, that doesn't work. So I'm going to try again. Try again. So that'll be x plus, and this time I'm going to put in 1 and 6 and see if that works. So now let's try that one. So that's x squared plus 6x plus 1x, which is just x, plus 6. So that's x squared plus 7x plus 6. Ta-da! That worked. Final question. Remember, if that last question was difficult, apologies. There's going to be some questions that are kind of just pushing a bit too hard and aren't really possible to do for you at this stage. I'll draw the axes. Obviously go away and have a go in your own time, but I imagine some of you have already twigged that if I'm drawing axes, you might want to pause the video after I've finished drawing the axes, so you're not then waiting on me. Okay, I managed to cram those in. I'm about to draw the answers. They're the answers. This is the last thing, so you can just finish the video whenever you like. Remember this one? For each of these, x is a different value, so y is the thing that's fixed, sure enough, therefore it's y equals 4. Happy. I think we're probably pretty happy with y equals x now. For every point on here, the x value is the same as the y value, the x value is the same as the y value, the x value is the same as the y value, hence the rule is y equals x. We've done this one before, y equals x squared. Remember, draw a table if you're not sure. So you might have put in x equals 0, which gives y equals 0, and then x equals 1, which gives y equals 1. And then maybe you tried x equals minus 1, which gave y equals 1. Oh, because squared makes 1, so it's positive. Oh, so it ends up going up as well, which makes the curve. And then you might have done minus 2, which makes 4. Oh, yeah. Okay, I'm happy. Now let's look at this one. This one is new. We'll do a little table again, just to kind of talk it through. What if x is 0? Then y is 0. So far the same as with x squared. What if x is 1? Y is 1. What if x is minus 1? What's minus 1? Oh yeah, because I've just lost it. So remember we're doing y equals x cubed. What's minus 1 cubed? What's minus 1 times minus 1 times minus 1? Minus 1 times minus 1 is 1. Oh yeah, because minus 1 cubed. Oh. So that goes down there. Oh, so this explains it, because if it's like, oh, let's use a different colour. If it's minus 2 times minus 2 times minus 2, that makes minus 8. So that's why it ends up looking like this. If that's the first time you've seen it, it's going to be bits of it that make sense, and every time you do it, you'll remember it a bit better. See you in the next video.